Hey guys, in this I think in this video we are going to discuss approximation of first order derivative by central difference or midpoint difference. I think in my last video we have discussed first order approximation of first order derivative by forward and backward. So let's refresh our mind by going through this. So you can find the Taylor's expansion around xi. We found the Taylor expansion, then we plug this number into this expansion, then we get this one. This is the error. So when you truncate your infinite series from here, so here we consider only first two terms of the infinite Taylor expansion. If you truncate from here, so you get this error here. This is the error term of if you truncate the Taylor expansion from here, you get this error, right? So when you rearrange this one, you can take this term to other side in order to make this term, right, and divide the whole equation through h. Then you get this one here. Then this one is the approximation and this one is the error. So error of this approximation, error of forward difference approximation of this first order derivative is proportional to h step size, right? So that means if you reduce the step size by half, so we expect to have the error half of the step size, right? Something like that. That's the so because the error is order h to the power 1, order is 1, so when you reduce step size by half, then we can expect the error is half of the step size. We explained this in my previous video. So also we have, so this is the forward approximation to this tangent to this point. So you can see the error, right? You can see there is a fair amount of error between these two, right? So this is the exact slope at this point, and this is the approximation. So if you reduce this step size by half, then we will expect to have error 1/2 of the previous step size, right? That's the main thing because the order is 1 here, right? So then what else we have discussed? This one, first order, backward approximation. This is the backward approximation of first order derivative. Now we consider the point behind. So xi minus 1 is a point behind xi. The length between these two is h. So h is defined as xi minus 1, right? Then you can write the Taylor expansion around you can write the Taylor expansion of f around xi, then you throw this value into that Taylor expansion, then you get this one. Then if you truncate your expansion from here, then you have to add the error. So this is the error when you truncate your infinite series from here, right? So this is the error. Capital R sub 2, what is that? yeah, this one, this is the error. So this psi is some value in between xi and xi plus 1. I hope you remember this. Now we are going to discuss central difference, this one here, right? So central difference approximation of first order derivative at this point, right? So for this we use these 2 points. So some people say this is midpoint difference approximation of first order derivative, right? So I like to use this one, central difference, right? So here we use these 2 points to approximate the derivative at this. We use these to see this secant line. The line joining these two is an approximation to this, right? So you can first write out the tail expansion around xi, then throw these values, and first write the tail expansion of f around xi, then plug this number into the tail expansion. You get this expression, this infinite series. Actually this should be equal to approximately equal to this one, right? This should be approximately equal to, so this value is approximately equal to this infinite series. Now you plug this value into the tail expansion. So do you remember the tail expansion? Where's that? So here, where's that? I haven't written that. Yeah. Give me a... Alright, this is the tail expansion of f around xi, right? Around xi. Now you plug this value into this infinite series, then you get this, right? So when you plug that one, you get this f of xi minus f prime of xi times h. So define your h. Your h is xi minus xi minus 1. This is your h, and this one is your h. Here h is positive all the time, right? And this h you can define xi plus 1 minus xi. So all the time we consider h is a positive, right? So this is a positive. Now this one is a positive gap, right? So then you can, so to find the central difference, you can subtract the second one from first one, right? Then you can cross this off. So this becomes 2 times f prime of xi times h. You can cross this one as well, cross these two as well. So this one you subtract this one from this. No, here we subtract this one from the first one, right? Okay, then we get this one minus this, left hand side, right hand side, 2 times f prime of xi h times 2 times of this. Now if you truncate this infinite series from here, right? So you truncate that, right? So when you truncate that, when you truncate that, so when you truncate this infinite series, so you had to now let's truncate this infinite series from here, right? Then you get C1. So f triple prime of C1 divided by factorial 3 times h to the power 3. The C1 is in between xi and xi here. This is so C1 is a value in between xi and xi plus 1, right? Now let's truncate the second one from here. So when you truncate that, you have to add the error term. This is the error term. So then there exists C2, right? This one is here. This is so here. Now we consider these two gaps. So this is the first we so this is the Taylor expansion around xi. Then we sub this value into there, then we get this. Then this is your C2. So C2 is located in between xi minus 1 and xi, right? This one, right? So now we subtract this one from this, and this we subtract this first second one from the first. Then we get what do you get? Yeah, this one here. You subtract the second one from first one, then you get this. This is your left hand side and this is your right hand side, and we know this is a value if f triple prime is continuous, so we can apply intermediate value theorem, right? So there exists a point in between these two values, xi minus 1 and xi plus 1, c in between. So the c is located in between xi minus 1 and x plus 1, right? Such that f triple prime of c is equal to this average, right? Then sub this one in, and then we get f prime evaluated at xi is equal to this central difference approximation. This is the central difference approximation to this one, right? And we get the order 2 error. So center differences this is the error, h to the power 2, right? So you can see that not like previous forward difference approximation and backward difference approximation. Here the order is 1, right here, so the order is 2, right? So this one is more accurate than previous forward difference approximation and backward difference approximation. Here this power is higher than previous two, right? So order is 2. If you minimize this gap, if you minimize this h by 1/10, so you will, if you minimize this h by 1/10, then we can expect your approximation get 1/100 times error, something like that, right? So this one is more accurate than the previous forward difference and backward difference approximations, right? So this is the central difference, central difference or midpoint difference approximation to the first order derivative at xi, right?